Hello, welcome to the second part of our second lesson in the factoring unit. That's unit 3 for our grade 10 academic math class. So we looked at factoring simple trinomials. Again, a simple trinomial being three terms, the quadratic term which has an a value that is 1. We're going to look at a little variation on that, which is what if we have a trinomial, like we have in example 1 here, where it doesn't start with a 1. It actually has a 3 out in front of the quadratic term. But what you can do is common factor a 3 out of each of the 3 terms. So this is calling back to lesson number 1. If you can common factor first, absolutely you should do it. So once you've common factored a 3 out of all 3 terms, you're left with x squared minus 2x minus 8, which is great because that now is inside the brackets. So never mind that 3 that's hanging out front. But this part here, that is a nice simple trinomial again. So we want to find the thing that multiplies to negative 8 but that adds to negative 2. The combination of factors are negative 4 and positive 2. We pop those guys in the brackets. Oh, and students typically ask this, does the order matter? For example, could the answer equally be 3, x minus 4, x plus 2? Absolutely. The order of those binomials is not important. The signs are very important, but the order of the brackets, like the binomials themselves, not important at all. So this is the new little twist that we're putting on. Can we common factor something out first? Let's have a gander. So here's the first one. Again, I've worked it out for you just to model it. So 2x squared plus 4x minus 48. Again, we have a 2 out front here, so this is no longer a simple trinomial, unless we can common factor a 2 out of this trinomial, and we can. And when we're done common factoring 2 out of our trinomial, we end up with 2x squared, we end up with x squared plus 2x minus 24, which is a trinomial that's simple. So we want to find the thing that multiplies to negative 24 and adds to plus 2. The combination that works are 6 and 4, with 6 being positive and 4 being negative. We take those two values and pop them into our brackets here, and we're good to go. Hopefully this is making sense and this isn't too much of a leap from where we were. Let's try B on our own. So 4x squared minus 4x minus 120. So not a simple trinomial, we have a 4 out front here. However, can we common factor a 4 out of each of the 3 terms in our trinomial? Yes, we can. And when we common factor 4 out of 4x squared, we're left with x squared. And when we factor a 4 out of negative 4x, we're left with negative x. And when we factor a 4 out of negative 120, we end up with negative 30. So now, inside the bracket, we have a simple trinomial that we can work with. So we want to find the thing that multiplies to negative 30 and that adds to negative 1. So same thing as before. Hit a pause here, see if you can finish this question up. When you got an answer, come on back and we'll see how you did. Okay, let's get a look at this. So we must carry this 4 down with us. That 4 cannot be abandoned, no number left behind. And now inside these brackets, we're going to go with x's at the beginning, thanks to our x squared. We're going to go with negative 6 and positive 5. And again, we can expand this out and simplify it, and we will get back where we started, which is 4x squared minus 4x minus 120. So this is good. Let's go try another one. This time we have x cubed plus 7x squared plus 10x. So this is looking a little different for us. It is a trinomial. There are 3 terms, and actually the first, the coefficient in front of the, in this case, cubic term is actually a 1, but this isn't a quadratic anymore. In factoring simple trinomials, these things must be quadratics, which means that we have a squared out front. However, in this case, we have something different that we can common factor out of all of this. The thing that is common to all 3 terms is an x. And when we common factor it out, we're left with x squared plus 7x plus 10, which is a nice simple trinomial. So now we want to find the thing that multiplies to plus 10. We want to find the combination that also adds to plus 7. Hit pause here and finish it up. When you're all done, come on back and we'll see how you did. Okay, again, can't forget that original common factored out x, but now we've got these 2 brackets hanging out. Each is going to begin with an x, and the combination is plus 2 plus 5. And again, I've said it once already, the order doesn't matter. This could be x bracket x plus 5 in brackets and x plus 2 in brackets. So it could be that way. There we go. Let's have a look at one more example here. 5x cubed minus 10x squared minus 75x. Okay, so this one has a lot more going on in it. It's definitely not a simple trinomial, and it's not a quadratic either. We have an x cubed at the beginning. So the greatest common factor, actually I want you to try this one too. Why don't you tell me what the greatest common factor is and do the greatest common factor for me. So again, hit pause here, see if you can pull out the greatest common factor, and then give me the resulting factored trinomial in the bracket. So hit pause, give it a go. Okay, welcome back. So the greatest common factor is going to be 5x, and that's going to leave us with an x squared here, a minus 2x, and 5 goes into 75 how many times? Come on, brain. 15, so negative 15. Okay, this is looking good. Hopefully you got here. Now again, we have that nice simple trinomial in the brackets. We want to find the thing that multiplies to negative 15, but that adds to negative 2. Again, hit a pause here. See if you can finish the question up. When you're all done, come on back and we'll see how you did. Okay. Again, we have to rewrite the 5x. We've got two brackets here. They will each begin with an x, and negative 5 plus 3 are the two factors that work for us. So this is how to do simple trinomials, but with a common factor to be factored out first. Now, I'm going to go through these extensions. I was going to stop the video, but we're actually only at about 7 minutes, so I think we'll have time to get these two done. This first extension is a little bit wild. It also calls back to the second or third part of our first lesson, which is where we looked at the fact that you can have common factors in terms that are binomials. And you can see by the way I've already highlighted this, that that's what we've set up here. We've got x squared, bracket x minus 1, close bracket. That's our first term. Plus 3x, bracket x minus 1, close bracket, second term. And minus 10, bracket x minus 1, close bracket, as our final third term. So what is the greatest common factor in all three of these? It happens to be that binomial, x minus 1. And when we common factor that binomial out of all three terms, we're left with x squared plus 3x minus 10. And again, the resulting trinomial is simple. So we can figure this thing out. We can factor it by finding the thing that multiplies to negative 10 that adds to plus 3. So give it a pause here. See if you can figure out the rest of this question. When you're all done, come on back. We'll see if you got it right. Okay, you're back. X minus 1. That's the original binomial that was common factored out. Now we've got two more brackets set up here. We have x, we've got x, we've got a plus 5 and a minus 2 as our combination that works for this question. Plus 5 times negative 2 gives us negative 10, and plus 5 subtract 2, or plus 5 plus negative 2 gives us our plus 3. So this, a little more complicated, but in principle it's the same thing. The real different add here is the binomial is the greatest common factor. And the last extension we're going to look at here has just an increase in the complexity of the variables. So what I do want to point out is that we know, just by looking at this, that this is starting out as a simple trinomial. We know that the first term in each bracket is going to be x. Never minding the 14, we also know that the last term in each bracket also has to contain a y. I'll just start sketching this out now. And the reason we know that is because there's x, and there's x, and there's y, and there's y. And we know this because when we expand out to simplify, there's our first one. That gives us the x squared right at the beginning. There's an xy term of some number, there's an xy term of some number, and there's a y squared term. So we know there's going to be a y squared term here. It doesn't actually change the fact that at its heart, this question is looking for two numbers that multiply to, in this case, I'm just going to change up my colors here. We're looking for two things that multiply to negative 14 and that add to negative 5. And again, I'm not ignoring the variables, I'm just not considering them as I try to figure out what the coefficients are going to be in front of the y terms, the last terms in our two binomials. So as I think about it, the two numbers that will multiply to -14 and that add to -5 will be, changing my colors again, -7 and +2. So I'm just going to erase some of this junk that makes it a little more confusing to see. So there it is. And again, just to say it one more time, the reason or the explanation for how I knew these y's would be here, this y and this y, were because this has a y squared here. There's only really one thing that multiplies together to give us a y squared, and that's a y times a y. So I knew they had to be there. Ignoring that then and just focusing on the x squared minus 5x minus 14, I was able to figure out what the coefficients are. So this is certainly the most challenging application that we're looking at. Hopefully this explanation works for you, that you kind of understand the procedure. If you don't, by all means, reach out to me via email. Otherwise, good luck with the homework, and we'll see you in lesson number 3.